Today's lesson is 8.3, circumference and arc length. Let's go ahead and get started with the circumference of a circle. This is the distance around the circle. So if I can start on any point on my circle, and I'm simply just going to go around. There are two different formulas due to the diameter, which is d, and the radius, which is r. So the only difference between these two is that the first formula is pi times d, and of course d stands for my diameter. And the second one is 2 times pi times r, and of course r is my radius. Now this would be my radius. Remember, the radius of a circle goes from the center of my circle, which is right here, out to the edge. And the diameter goes from side to side through the center point. It has to go through the center. Just a quick reminder that the radius is equal to half of the diameter, and that the diameter is equal to 2 times the radius. Okay, just in case we have to go back and forth. But normally what's going to happen is you will see one or the other, and then that will dictate which formula you use. Do you have the radius? You use this formula. Do you know the diameter? You use that formula. All right, let's go ahead and get started. Find the circumference of a circle with a radius of 3 centimeters. So I'm going to go ahead and grab my highlighter. Notice it does say a radius of 3 centimeters, and it is asking me to find the circumference. All right, I'm going to choose this formula because it does say radius, and that's why I chose the blue marker, the blue highlighter. And so here is my formula. And remember, there are multiplications hiding in here. Now be careful when you go into Alex is going to either ask you to use 3.14 for pi, or it's going to ask you to leave it in terms of pi. And so we'll be seeing both of those today in the lesson, and how to look for that, okay? So I'm going to go ahead and fill it in. 2 times pi times 3. Now, if Alex says to leave your answer in terms of pi, you are simply going to multiply 2 times 3, and you're going to leave pi like it was a variable, which means you're not going to actually put it into your calculator, and you would leave your answer like this, and you would put your units as centimeters. Now, if Alex asks you to use 3.14 for pi, then you're going to go ahead and you're going to grab your calculator. Let's grab our calculator. And you're simply going to do 6 times 3.14. 0.14. And you're not going to go ahead and round. Could I flip it into a fraction? Yes, I can, but Alex will not ask you to round. It will ask you to just give your answer because it's already rounding pi for you at 3.14. So there we go. There could be our two answers, just depending on what Alex asks you for. So just a quick reminder, this is leave in terms of, I forgot the E, of pi. So pi acts like a variable, and we just do not multiply by it. We put it in our answer like we would an x. And then this one will say use 3.14 for pi. All right, let's go ahead and take a look at the next example. Find the radius of a circle if the circumference is 24 meters. So notice it says the circumference is 24 meters, and it is asking me to find the radius. I'm going to go ahead and use this formula once again. 2 times pi times the radius. But this time, I'm going to put the 24 here, And then I'm going to leave, this is my answer. Now what they want me to do is they want me to get the variable of r by itself. Notice that there is multiplication hiding in here. So to get rid of multiplication, I am simply going to divide. Since both of these are multiplication, I can think of them as being together and there being the one multiplication. So I'm going to go ahead and think of them as being together 2 times pi, 2 times 3.14, and then I can go ahead and divide by 2 pi because they would act like a 2x. All right. Now, what I'm going to do is I'm going to grab my calculator and I'm going to put this into my calculator. So let me grab my calculator. There we go. Let's go ahead and clear this out. I'm going to go ahead and make my fraction. 4, there we go. And I'm going to put on the bottom 2 times 3.14. Alex seems to like to use that for pi instead of the pi key. So there we go. If I were to round, I'd probably round to 2 decimal places. So 8, and it looks like the 2 is going to stay at 2 because behind it is a 1. All right, and my unit, of course, would be just meters because we're talking about the radius and not the area. All right. Circles that lie in the same plane and have the same center are called concentric circles. Notice my picture below. I have a circle inside of a circle right here. And when this happens, I'm just either going to add or subtract depending on what the problem tells me to do to find whatever it is that they want me to find. So the radii of 2 concentric circles are 5 inches and 3 inches. Find the difference in their circumferences. So notice they are telling me that there are radii. This is a pluralization of radius. So they're showing me that I have 2 radiuses, and then they call them radii. And they're asking me to find the difference of their circumferences. Difference, of course, means that we are going to subtract. All right, and this, of course, is radius. There's one radius, there's the other radius. Okay, so I'm going to go ahead and do the circumference of the first circle, and I'm going to do the circumference of the circle where the radius is 5. So I'm going to do the larger of the two first because I am subtracting. So I always do the outside minus the inside. I'm going to do 2 times pi times r. Let me add that over here. I'm going to go ahead and do 2 times 5 is 10, and I'm going to leave the pi for right now. Now I'm going to go ahead and do the circle inside where my radius is 3. So 2 times pi times 3. I'm going to do the 2 times 3, which gives me 6 pi. It is asking me to find the differences, so I'm going to go ahead and subtract. 10 pi minus 6 pi would give me 4 pi. So this is if I was in leaving it in terms of pi. If Alex asks for that, my answer would be 4 inches. Or I would go into my calculator and I would do 4 times 3.14, 12.56 inches. Remember, we're talking circumference, so it's just inches. We do not square it. All right, let's move on to the arc length. The arc length is a fraction of the the arc length of a fraction is a fraction of the circumference of a circle. So the arc length, let me go ahead and grab a different color. Okay, the arc length is just this part right here. The whole circumference of the circle would be this, but we only want this little bitty piece of it. This is called the arc length. To find the arc length, I need to know the measure of that arc. So how many degrees is this angle? Because remember, the degrees of this angle match the degree of that arc, divided by 360, because that's how many degrees are in a full circle, times 2 pi r. Notice this is the circumference, right? This is the circumference formula. One thing to note is that the measure of the arc and the 360 both are in degrees. They are both in degrees. All right, let's go ahead and do our example right here. Find the length of arc AC. So I'm going to grab my highlighter. They want to know the length of this. Okay, and this is my arc length. Notice they are talking about length. So I'm going to use the formula from above, and I'm going to say arc length equals. Now remember, the measure of the arc, it needs to be in degrees. So that would be the 50 right here. And I'm going to put my degrees. And then in the denominator, I always put 360 because I'm comparing it to the whole circle. And then I'm simply going to multiply by 2 pi, and my radius, let me go find my radius. There's my radius right there, 3 centimeters. Okay. Now, when you do this problem in ALEX, it is going to ask you to leave the arc length in terms of pi. So I am not going to multiply by pi at all. I'm just going to continue pi throughout my answer, keeping it like it were a variable. So I'm going to grab my calculator because it's going to be my best friend. What I'm going to do first is I'm going to simplify this fraction. So I'm going to put in the calculator 50 divided by 360 and make the decimals calculator simplify that for me. Then I am also going to, in this first step, do 2 times 3 because remember, I need to leave the pi alone. Here we go. Grab my calculator. Nope. No. There we go. It always takes just a little bit of time. All right, here we go. Let's clear it off. I'm going to use that A over B like I've been showing you. And I'm just going to do 50 divided by 360. There we go. Notice that Desmos does give me a fraction. I'm going to go ahead and change that into a it does give me the decimal. I need to change it into the fraction. So I'm going to go ahead and say 5 over 36 times 6, 2 times 3, 2 times 3, that's where the 6 came from, okay, pi. All right, now what I'm going to do is I'm going to come in, I'm going to get out here, I'm out of my fraction, and I'm going to hit times 6, and it's going to stay in the fraction for me. If it goes back to the decimal, just go ahead and click the circle, and it'll go back to the fraction for you. Once again, I did 5 over 36 times 6. Well, I left it as 50 over 360 times 6. Ooh, I wonder, is that correct? Yeah, that's right. All right, so my answer will be 5 over 6 pi, and my units are going to be centimeters, just centimeters because we are talking about length. And remember, the arc length is just a part of the circumference, just a part of the circumference. Let's try one more. Let's try one more. And I'm going to leave my calculator up because notice it does ask me to find the length of ADC. I'm going to follow them in order from A to D to C. Oh my goodness. Okay. Now notice what they've shown me here. They have shown me that this arc is 80 degrees because this angle is 80 degrees. I don't know how many degrees this arc angle is, so I don't know how many degrees this arc is. But wait, I know that a circle is 360 degrees. So if I were to take away the 80 degrees from the minor arc from A to C, this part right here, then I would know how many degrees this arc is, which would also be this angle inside as well. So 360 minus 80 gives me 280 degrees. Yep, just checking to make sure I'm correct. All right, now I'm going to go ahead. Now that I know that this is 280 degrees, let me add that in there. Okay, I can go ahead and use my arc length formula. So my arc length is equal to the measure of ADC's arc divided by 360 degrees times 2 pi r. Once again, Alex is going to ask you to leave your answer in terms of pi. So my measure of ADC is equal to 280 divided by 360 times 2 pi, and my radius, oh, I can't see my radius. There's my radius right there, 12. All right, what's going in my calculator? Well, I'm going to put in my calculator 280 over 360. I don't know why that 6 doesn't want to. There we go, 7 over 9. Now I'm going to go ahead and I'm also going to multiply 2 times 12. 2 times 12 is 24. Okay, so once again, I got the 24. I got the 24 from 2 times 12. Okay, because remember, we're leaving pi just like it was a variable. So I'm going to go ahead and 7 over 9 times 24. I'm not multiplying by pi. I'm going to go ahead and change that into a fraction. 56 over 3 pi, and my units were feet.